Today we'll be looking at inverse functions, and I will be working our way through how to first of all form the inverse functions, also when is an inverse function applicable, and we'll also be looking at how to find the range and domain of the inverse function and also drawing inverse functions. Okay, first of all, what is an inverse function? Well, an inverse function is a function which basically undoes the original function. Okay, so as the word inverse suggests, it undoes the original function. And to find it, I've written out 3 steps of how to find it quite simply. So the first step is we let our function equal to y, and then we rearrange to make x the subject. And finally, we have to replace the appropriate form. What I mean by this is, well, we're going to end up with some x, and we're going to change that into our inverse function. And we're going to also end up with some y, and we're going to change that back into our x. So it might seem a bit complicated now, but we'll work through some examples together just to see how this works out. A couple of things to note. First of all, an inverse function only works for a one-to-one function, as shown here. Okay? So one-to-one function means you put in one x value and you get one y value. So it wouldn't work for like a many-to-one function or one-to-many functions, stuff like this. Okay? And finally, the range and domain. Well, the range of our original function is actually equal to the domain of the inverse function, and vice versa. So the domain of the function will be equal to the range of our inverse function. Okay, so we'll just work our way through some examples. The first one I want to do is this f of x is equal to 2x plus 1. And as you can see the domain x is bigger than 2. The domain being just what the x values can be. Okay, so in this example, x is going to be bigger than 2. So to find the inverse function, well, our first step is to let our f of x equal to y. So we'll say that y is equal to 2x plus 1, like such. Now we have to make x the subject, so rearranging for x essentially. So we'll bring the 1 to the left-hand side, so we have y minus 1, that's equal to 2x. And if we divide it by 2, then we'll be left with our x. So x will be equal to y minus 1 over 2, very simply like that. And our final step is replace back to appropriate form. So our x will now turn into our inverse function, so f of minus 1 of x. And that is equal to our y, which we replace back with our x. So we have x minus 1 over 2. So this is our inverse function, x minus 1 over 2, and of this original function here. Okay, so we can also find the range and domain of the inverse. So as you can see here, the domain of the inverse is the range of the function, and the domain of the function is the range of the inverse. So we are given this domain of the function here, x being bigger than 2. That means the range of our inverse function would also be bigger than 2. So the range of the inverse will be bigger than 2. Right, to find the domain, we need to find the range of our function. So the best way to do this is drawing graphs. So let's try and plot this graph. So it's a 2x plus 1. So that's a straight line graph going past y is 1. And we have a given domain, so we're only looking at the values for x being bigger than 2. So if you have a 2 here, we're just looking for the values of x being bigger than 2, like such. So when x is 2, our y value is going to be 5. So therefore, the range of our function, if we were asked to find that, the range of our function would be any value bigger than 5. And as you can see, the range of the function will be the domain of the inverse. That means the domain of the inverse, x, will be bigger than 5. Okay, so as you can see, this is how they're related. To plot the graph now, well, if we want to plot this inverse graph, well, we can just plot this equation, couldn't we? Or another way we could do it is we could reflect the function along the line y is equal to x. So if you want to find or plot the inverse graph, all you have to do is reflect the original function along the line y is equal to x. So I'll show you this in a couple more examples in a bit. So let's move on to the next example here. So we got our function f of x is equal to x squared plus 2. First of all, finding the inverse, well, we let y equal to the function, so it's y is equal to x squared plus 2. We then rearrange for x, so we have y minus 2, that will be equal to x squared. And then if we square root this, then we'll just be left with x. Finally, we just replace back to appropriate form, so this x becomes the inverse function, and the y becomes x, so it would be the root of x minus 2. So here is our inverse function. Okay, so to find the range and domain, so we know we're not given a domain for this function, right? But an important thing to note is it only works for a one-to-one function, as I explained before. And so if I was to plot this graph, x squared plus 2, well, it's going to be like it's a quadratic graph, like looking like this, right? Where y is 2. And this is not a one-to-one function. Why? Because we have several x's, in fact 2 x's, which will give you the same y. So this is an example of a many-to-one function. Okay? So technically, we can't find the inverse function for this graph. So in order to do this, what we can do is set a certain domain. So I can make this into a one-to-one function by setting a domain. So what I can say is, well, let's limit the x values to x being bigger than 0. That way, we can disregard this left-hand side of the function and just be left with the right-hand side. And now we've changed it into a one-to-one function. And because we've changed it into a one-to-one function, it means that we can find the inverse function, or the inverse function exists. So let's use this domain, x being bigger than 0. So x being bigger than 0 is the domain, which means it's the range of the inverse. So straight away we can work out the range f that is going to be bigger than 0, the range of the inverse. And to find the domain, well, we just need to find the range of this original function. The smallest value this function can take, if it's limited to being bigger than 0, is this 2 value right here. So the range of the function f of x will be bigger than 2, which in turn will mean that the domain of the inverse is also bigger than 2. Okay? And finally, just to plot the graph, well, as we said, we can reflect it along the line y is equal to x. So if I draw a straight line graph, or the line y is equal to x like such, we just simply have to reflect it, okay, along this line. So it will look something like this, okay, where this point is 2. So this will be the inverse function graph if we were to ask to plot it. And this will be the original function, like such. All right, let's move on to another example. So let's move on to this. It's a quadratic equation again, but it's slightly different. So as you can see, at first glance, well, first of all, let's replace with y. So y is equal to x squared plus 5x plus 4. And as you can see, it seems a bit difficult to just make x the subject. So whenever you're met with this kind of question, what we want to try and do is complete the square. So we have to complete the square means we divide it by 2. So we have x plus 5 over 2 all squared minus 5 over 2 squared plus 4. Just simplifying this a bit, so we have x plus 5 over 2 all squared minus, this becomes 25 over 4 plus 4 will give you 9 over 4, like such. And now we can rearrange for x. So I'll bring the 9 over 4 to the left-hand side. So y plus 9 over 4 will be equal to your x plus 5 over 2 all squared. Square rooting it. Y plus 9 over 4 will give you x plus 5 over 2. And then if you minus the 5 over 2, that will leave you with your x. So your x is equal to minus 5 over 2 plus the square root of y plus 9 over 4. So we've replaced it back with x, and now just replace it into an appropriate form. So your inverse function, f of minus 1 of x, will be equal to minus 5 over 2 plus the square root of x plus 9 over 4. So this is your inverse function. So if you're met with a quadratic equation like this, well, all you have to do is try and complete the square, and then you can rearrange for x. Right, so find the range and domain. Technically, this is also like the previous example. If we were to plot this graph, well, if we were to factorize, you get x plus 4, x plus 1. So it will look something like this, the graph. And as you can see, this is not a one-to-one function. It's actually a many-to-one function, as before. So technically, the inverse function will not exist unless we set a certain domain. So different exam questions or questions will set a certain domain so that you can create an inverse function, and then you can plot that inverse function. The next example I want to do is an exponential function. So we have f of x is equal to 2e to the 4x minus 1. And we've given a domain, x being any real numbers or all real numbers. So let's go about trying to find the inverse. So our y will be equal to 2e to the 4x minus 1. Bring the 1 to the other side, so we have y plus 1 is equal to 2e to the 4x. Divided by 2, y plus 1 over 2 is equal to e to the 4x. Hopefully we all know that we can apply natural logs. So ln y plus 1 over 2 will give you 4x, and therefore x will give you 1 over 4 ln y plus 1 over 2. So we've rearranged for x. Final step, just replace the appropriate form. So we have the inverse function f of minus 1 of x will be equal to 1 over 4 ln, and then we'll have x plus 1 over 2. Okay, so this is the inverse function of the original function. Let's quickly find the range and domain. So we're given the domain of the function. We should know by now that's the range of the inverse. So the range of the inverse we can say is going to be all real numbers. To find the domain, the inverse, we have to find the range of the function. So let's plot this graph just to see what the graph looks like. So it's an exponential graph and it's been transformed. So the asymptote is going to be at y is equal to -1. And it will look something like this. If you're still stuck on graph transformations, I'll post another video about graph transformations later on. So this is the function, as we can see here. And if x is any real numbers, meaning it can be any number, then the y value, the smallest y value can be is -1. In fact, it can't be -1. So any y value you can take is going to have to be bigger than -1. So the range of the function is just going to be any value bigger than -1. And if we find the range of the function, then we know that's going to be equal to the domain of the inverse. So the domain of the inverse is going to be any value bigger than -1, like such. We can also quickly draw this function as well. So we know that we can just reflect it along the line y is equal to x, like such. So the original asymptote was y is equal to -1. That means the asymptote for the inverse will be at x is equal to -1. So if I was to draw a line, x is equal to -1. And it will look something like just trying to reflect along this graph, something like this. So this will be your inverse function graph. Okay, and finally, I want to move on to the last example I want to do. So it's a 1 over x plus 5 example. So let's just try and find the inverse quickly. So y is equal to 1 over x plus 5. And then we can rearrange for x. So we have x plus 5 is equal to 1 over y. X will therefore be equal to 1 over y minus 5. I will just simplify this. I'll combine it into one fraction. So we get 1 minus 5y over y. Our final step is to replace back into our inverse equation. So the f of minus 1 of x will be equal to 1 minus 5x over x. Right, so straight away we can find the range of the inverse because we're given the domain of the function. So the range will be the same as the domain of the function, meaning that the f of minus 1 of x will be bigger than 0 and all real numbers. I won't write that part. And we also need to find the domain, so we just have to find the range of the original function. Easiest way, as we said before, is just by plotting a graph. We know that the asymptote is at x is at -5. X is equal to -5. However, so it will look something like this. But we are given a certain domain, aren't we? X being bigger than 0. So we don't technically need this portion of the graph here. Okay, we're only looking at this portion of the graph here. So at this part, what is the range? Well, as you can see, as x gets bigger and bigger and bigger, y will get smaller and smaller and smaller. So the maximum value you can take is at this point here, when x is equal to 0. If you put x is equal to 0 into this function, you get 1 over 5. So we know that the range of the function, f of x, is going to be less than 1 over 5. However, as you can see, there's also an asymptote at y is equal to 0 as well, as it's never going to get to the negative section, so it's going to be bigger than 0. This will be your domain of the function inverse, so that means that x will be bigger than 0, but less than 1 over 5. So hopefully you guys can see how to find the inverse functions and how to also find the range and domain of these inverses and how to plot the graphs. If you have any questions, just write them down below and we'll try and get back to you as soon as possible. And I'll see you in the next video.